In this video, I'd like to go over the parabola, including the equation of the parabola and how to graph a parabola. Here are the two equations of a parabola. In either case, you can find the vertex by using the values h and k. H is the value that's subtracted from the x, and k is the value that's subtracted from the y. I'll refer to the first equation as the y squared parabola and the second equation as the x squared parabola. The y squared parabola opens to the left or to the right, and it has a directrix, which is a vertical line. It opens left if the p-value is negative and right if the p-value is positive. For the x squared parabola, it either opens up or down. The directrix is a horizontal line, and the parabola is up if the p-value is positive and down if the p-value is negative. In either case, the vertex is where that parabola changes direction. For the y squared parabola, the focus is at h plus p, comma k, and the directrix is at x is equal to h minus p. Essentially, that means that if you look at the vertex, you're adding p to find the focus and you're subtracting p to find the directrix. Let's say if we just look at an example of a y squared parabola that opens to the right. You add p to get to your focus, and you subtract p to get to your directrix. And you're adding and subtracting the p specifically to the x values. And it's switched for the x squared parabola. The focus is at hk plus p, and the directrix is at y is equal to k minus p. If we look at a parabola that's upward facing, you're essentially just going to add p to the y values to find the focus and subtract p from the y value to find the directrix. Now let's look at an example where you have to graph the parabola y minus 1 squared is equal to 24 times x plus 7. Notice that it's a y squared parabola, so we're going to use that equation. First, let's find the vertex, h comma k, which in this case is negative 7 comma 1. Then we'll find the value for p. If 4p is equal to 24, dividing both sides by 4 lets us know that p is equal to 6. Now let's start by plotting the vertex. If I draw an xy plane, I'll plot the vertex at negative 7 comma 1, and I also might take a note that since the p-value is positive, I know that it's going to be a parabola opening up to the right. Next I want to find the focus, and to do this I'm going to add p to the x value of the vertex, which makes it negative 1 comma 1. So from the point where I have the vertex on my graph, I'm just going to count over to the right 6 and plot that point for the focus. Now let's find the directrix. So for this I'm going to subtract 6 from the vertex, which gives us a directrix at the vertical line x is equal to negative 13. Now I want to take a quick break from our example to go over something called the lattice rectum. It's defined as the absolute value of 4p, and what it is the distance of the line that goes through the focus is parallel to the directrix and has endpoints on the graph of the parabola. So this is the last piece of graphing parabolas that we'll need because we have to find another point on our graph, and we can use the lattice rectum to find that. So if this is our directrix, a horizontal line, and we have an upward-facing parabola, then if we draw a line through the focus and parallel to the directrix, that would be the distance of the lattice. So the lattice for this example is the absolute value of 4p, which is the absolute value of 24, which is 24. I'm going to look specifically at half of that amount because I want to start at the focus and count down 12, which brings me to negative 1 comma negative 11, and then I'm going to count up 12, which brings me to the point negative 1 comma 13. The total distance there is our lattice distance, which is 24, and now I'm just going to graph a line through those 3 points. So using those 5 steps, you can graph either a y squared or an x squared parabola. So vertex, p-value, focus, directrix, and lattice. I hope this helps.